Hi guys, and welcome to weekend 2 of my 26 weeks of Leetcode challenges. Last weekend I had a look at challenge 288. I stopped midway because I was too slow, and this weekend I'm just going to continue with that challenge. In the meantime, if you're new to Leetcode contests, they're a great way, I think, to just have fun and improve your algorithms, your skills at algorithms and coding challenges in general. And typically they're sponsored by companies like Funfair and Airwallex and sometimes even Amazon. But yeah, let's I'm gonna jump into today's focus. Weekly contest 288. And very importantly, I'm gonna remember this time to start the virtual contest. Um Good. Also, in terms of timing, I'd like to spend about maybe 1 hour to, yeah, just roughly 1 hour. Each contest is typically just an hour and a half for 4 questions. Um, ooh, interesting. And last week or last weekend, I saw these 2 questions. I honestly expected them to be green, given that I already solved them last weekend. And I think that's important because it's something I want to highlight. When you solve a question, if you want to see your previous solution, you can always just come here, replace with the last submitted code, and you can, keep working from the last code you submitted. So that's accepted. And then when you when you when when you have a solution accepted, it goes green. And let's do the same thing for the second one. But first of all, yeah, let's just load in the code that I last submitted. Um, so last week, where I struggled was in terms of modifying a string, which is an immutable data structure in multiple places at once. And the way I tried to go about that was by concatenating um, substrings, subsections of that string. So after after I after I wasn't successful at that within the time limit, I just stopped and then I went back to it and instead chose to use an array. So let's see if I can refresh my memory here. So we are building an expression. We're building an expression that looks like this, right? But more fully, we're building an expression that looks like this, but it's also syntactically correct JavaScript with the multiplication operands. So more like this. Um, and in order to build this expression, we're inserting an open brace or a closed brace and a multiplicand operator at some point in the original string of this, right? Each string will always have an addition operator and then some number on the left and right hand side. And yeah, so initially I was just going to for every I and k, which is opening brace, closing brace, concat the string in such a way that I end up inserting the opening brace on the ith position and the closing brace on the kth position. But that didn't work out, and I opted for an array instead. So first thing I do is for every possible option of I and k, create an empty array, and then I push the substring starting from 0 up until I, so I is 0 initially, but up until where the opening brace is supposed to be. And yeah, I push that substring into the array, and then I push the opening brace, and then I push the rest of the substring before the plus operand into the array, then I push the plus operand, and then do the same thing for the closing brace basically. And when I'm done, I just check special cases. So if we are starting, if I is 0, then we know that we don't want a multiplicative operand, otherwise it's not valid JavaScript. So if I is not 0, then we want that and we push that to the first location, given that we know that this string will always be in the first operation. The opening brace string will always be in the first index, rather, in the operation. And then we do the same thing for the right hand side. So if it's not the last last index, we what do we want? if it's not the last index yet, then we want the multiplicative operand. If it's the last index, we just want a closing brace. And when we're done, we push the we we join all the strings together to form one string, and then we push that expression into an array of evaluations we want to evaluate. And yeah, that was basically it. The algorithm I chose initially to solve this problem remained the same. I didn't change anything. It's just I had to modify my approach to how to push multiple characters into a string. I'm sure there are better ways to do this, but I just went with that. With that. What else? What else? What else? What else? What else? What else? Yeah. So I may as well just complete this by saying I reduce. We're looking for the expression that gives the smallest value, so that's what we're doing here. Of all the expressions in the array of expressions to evaluate, we take the previous expression, we take the current expression, and we run an evaluation on the previous, we run an evaluation on the current, and if the value from the previous is less than the value from the current, we return the previous, else we maintain the current. At the end of the day, we end up with the expression that gives the smallest value, and that's pretty much it. When we return, and before we finalize our return statement, we have to remove the multiplicative operand we introduced to make it valid JavaScript, and that's pretty much it. I believe that was accepted, so let's submit. I will remove all these comments just because we don't need them anymore. Yeah, so that was accepted, and moving on. If we go back here, we can see that we've accepted 2. So now let's go to the last 2 problems of context 288. Typically these problems are graph problems or linear programming problems or dynamic programming problems, right? And what I did between last week and now was I spent some time reading through Leetcode's resource on graphs, right? I didn't go that far. I spent most of my time just memorizing the union find algorithms in terms of quick union, quick find, and quick find with optimized path, and quick find with optimized path, and by rank optimization as well. So basically, I was all my time allotted to this during the week went to quick union. So like if we come across with some problem that needs Dijkstra, some problem that needs DFS or BFS, I will not be fluent, but that's part of practice, right? Hopefully I am able to solve it within like the next 1 hour. Even if I'm able to solve it within like the next 1 hour, next week I will spend time memorizing DFS, BFS, just making sure I can create that without thinking, like regurgitate those algorithms without thinking about them. Yeah, and I think this is a good approach to take. I think this is I mean, it's not battle tested, but I do think it's a good approach to take when you consider that these algorithms themselves took years and years to be, like, before each one came out in terms of being invented. So the idea that when you understand it, you don't need to memorize it, I don't know, hasn't really worked for me. That's what I was working on before. Like, once I understand it, I don't feel the need. I never felt the need to memorize these algorithms. But if you're watching this and you're thinking, oh, how should I approach Leetcode contests? My suggestion would be, understand your algorithms definitely, but once you understand them, also like commit them to memory, memorize them, use spaced repetitions, make sure they stick, that kind of thing. So yeah, going into the next problem, maximum product after K increments. Let's close that tab. Maximum product after K increments. I'm gonna just try and skip straight to the input-output explanation. So given an array 0, 4, and K 5, the output is 20. First of all, they increment the first number 5 times. Okay, I guess that means they get 5. And now nums equals 5, 4 with a product of 5 times 4 is equal to 20. It can be shown that 20 is the maximum product possible, so we return 20. Note that there may be other ways to increment nums to have the maximum product. Okay, that makes sense. I mean, no matter how much we incremented, yeah, that makes sense. If we incremented this even just one time and then spend the rest of the energy incrementing 4, we would only arrive at 8 in total. versus incrementing this to 5 and multiplying that by 4. So now looking at the second one, just to increment, just looking at it, I think it's I guess if we increment 6 to 8, that may give us the max. Okay, no. Turns out we want to increment this to 4 and this to 3. Interesting. Okay, so in 4, 3. Okay. Increment the second number one time and increment the fourth number one time. 6, 4, 3, 3 with a product of. I'm sure that is a. Okay, so I mean, without reading this, I think we understand the problem just by the problem instantiation. Oh, by the way, I have been reading introduction to algorithms, and it's it's just one of those small things. So in one paragraph, I read how, like, once you have all the inputs to a problem, and you have the expected. Yeah, once you have all the inputs to a problem and you know what to expect, that's a full instantiation of the problem. So, like, I think the value in reading that, reading that as explicitly as it was, is realizing that I don't really need to. For most problems, I don't think you ever really need to read this part of the problem. I mean, when you're thinking about edge cases, yes, but for at least I think simpler problems, I'm gonna just try looking at the problem instantiation in terms of the inputs, the outputs, and the explanation that Leetcode provides. I don't know how well that will apply to real life situations in terms of coding interviews, because I don't think that most coding interviews provide explanations, but we'll see. Right, so back to the problem. First thing that came to mind is there some mathematical axiom that dictates the way in which we can generate a maximum number from a sequence of numbers? So is there something that says, maybe, for instance, that to generate the maximum number, the first number needs to be, to generate the maximum multiplication from all the digits in a number, you need to have the maximum number possible by forming what do you call it? Yeah, the maximum number possible in terms of 6433, not 6. Oh, although 6533, 6532 is bigger than 6433. So anyway, that particular instance of is there a mathematical axiom doesn't hold. So what other ideas do I have? Can I think of any? Nothing comes to mind. Let's give that like 10-15 more seconds. So 6, 4. First of all, we have 6332. We can only increment 2 numbers. But after incrementing 2 numbers, we want to make sure that the multiplication of all the numbers gives us the maximum possible number. I think about 10 seconds over. So 10 seconds, no ideas. Let's go for brute force approach. Brute force approach is try and increment every single number. Try out every single possible type of increment, and then optimize, and then return the increment that return the maximum number. Now that is super inefficient, but it's what is straightforward. So let's go with that. The array, the number itself is broken down into just an array. It's already broken down into an array. I'm guessing some variations of this problem will just give you a number, and then you have to use that modulus operation that we did in the previous problem, in the first problem, to break it down to digits. So this makes it simpler for us. So the next thing is, okay, how do we actually go through all the different possible ways of incrementing all the different possible numbers? That depends on k, right? So let's start with k is 1. Take k is 1 and we have 0, 4. All the possible ways we could increment all the possible numbers is just by going through the numbers one by one. So 1 or, so either 1, 4 or 0, 5. What happens if k is 2? I'm doing this because I really don't know the answer to this, but if there is a pattern to it, then the easiest way to find the pattern is just by doing it. So I've learned. So what happens if k is 2? Now if k is 2, we can do increment the first one twice, increment the second one twice, increment the first one and increment the second one. I think that's about it. So let's start with incrementing them by 1, 4, or by, okay, so 1, 4 or 0, 5, or 2, 4, or 0, 6. Let's go to 3, 0, 4, and then same thing. I mean, the first case will be 1, 4, yeah, 1, 4, 0, 5, or, I mean, this is case 3, right? We know we can do 2 or 4 or 0 or 6 or, so that's case 2. How about case 3? So case 2, case 3. So I guess the next thing is 3 or 4 or 0 or what do you call it? Or 7. So it looks like the pattern is given for any k. First of all, you can increment every. I think the pattern is just for every given k, you loop through k, and for every iteration of k, you increment every single digit by k. By the time you're done, will you have every possible iteration of every possible way to increment all the digits in k? So I don't know. I don't think so. So well, I guess so. So let's try it out with 6, 3, 3, 2. Starting with k is 2. So starting with k is equals to 1, what we'll get is 7, 7, 3, 3, 2, or how do I do this quickly? Let me just type it sequentially. So we get is 7, 3, 3, 2, or 6, 4. 6, 4, 3, 2, or 6, 3, 4, 2, or, I mean, doing this doesn't prove that we're correct. Well, let's see, 6, 3, 4, 2, or 6, 3, 3, 3. Right, so that's just case 1. We have this possibility: 6, 4, 3, 2, 6, 3, 4, 2, 6, 3, 3, 3. The answer, wait, I think we've done something wrong. 6, 3, 3, 2, 7, 3, 3, 2. So incrementing the first one, incrementing the second one, we have 6, 4, 3, 2. Incrementing the third one, 6, 3, 4, 2. Incrementing the fourth one, 6, 3, 3, 6, 3, 3, 3. Something seems off with 6. Well, k is just 1. Let's try case 2. So yeah, this won't work. That won't work. That pattern won't work. With case 2, we'll have in the second position 5 at a minimum. In the fourth position 4 at a minimum. So the k is 1 missed out on k is 1. It seems so obvious. I should be able to see it. 6, 3, 3, 2. How do you spread? Okay, let me just look at this a bit differently. If we could look at k equals to as distinct values. Okay, I see. Okay. All right. So if we look at this as the first level, on the second level we can go through every one of these and increment them by one. So what I mean is, let's put on a new line. And now on the second level or second iteration of k, so this was k equals to 1, and then when k is equal to 2, we're doing the same thing. We're just going through. Wow, that would be a lot. That's a lot. We'll want to do that for every single one of these. Playing out 8, what do you call it? Yeah, we only have one left, one increment left, so 8, 3, 3, 2. And I think this will, when played out, this will give us all the possible variations, all the possible ways in which we can. I'm thinking of it in terms of assigning k to associating a unit of k with a number in a digit in. So I'm just thinking of k as, if k is 2 as 1 1, and all the ways we can associate 1 1 with 6 3 3 2. So which one will give us our winning formula? I think it'll be this one, 6 4 3 3, right? So in 6 3 3 3, what we'll get initially is 7 3 3 3, and then we'll have 6 4 3 3, which, yeah, seems good enough to me. So that's just a for loop, double for loop, or it's not a double for loop, it's a what is that? For every digit in this one, the first iteration is increment every single index, and then for every, and then what do? You push all of those into, and then push all of those into some place, and then for every one of those, increment. So we are doing a single increment every single increment. You're doing a single operation of incrementing every single digit in the array. You're doing another operation of pushing all of those into some store, and for every item in that store. Okay. Wow. It's still not clear. So what we'll have is some store of possibilities, or let's just say constant possibilities. And let's comment this out. The first step for, let's see, I will use this I less than nums of length I plus plus. The first step is basically doing let's just do this. Nums I, get the value, equals to 1. And I'm suggesting that we do, let's just do in one line. Well, I'm suggesting that for all these values, just the possibilities, push this. That's a good name. I like evals. There we go. So evals will push that value. And how many times do we want to do this? That's not the question. That's not the right question. The right question is, actually, just give me a sec. I need to attend to something. Let's pause this. Hi, I'm back. Yeah, so the right question is not how many times I want to do this, but let's just keep this as some operation we want to perform. What we really want to do is, while we haven't exhausted the number of cycles in K, we want to perform this operation after each cycle. It's not clear. Oh god. Yeah, but yeah, after the first cycle, we want to look into evals and then perform this operation again. Okay, I see. So what does this mean? It means we initialize this with norms. And then what? And then we say, we can use a for loop. Let's use a for loop. Let c is equal to 0, c less than k, c++, c++. We want to perform this operation, but the operation we want to perform is not just this. It's a for, oh my god, this is enqueue to find all possible. Okay, well, let's just keep going. It's not enqueue because we have different sizes of the arrays. But anyway, first thing is, for every okay. Go through evals, but we don't want to go through things we have already seen before. That's one sure optimization. When we look at this, what does this give us? This gives us a matrix. So we're creating a matrix actually. This gives us something that at least, okay, nums at length by nums at length from the looks of it. Why doesn't K factor into this side of this matrix? Just something wrong. I'm not seeing. One. This was where we started. Then we got this. The only reason this is m by the output of this plus output we get if k were 3 we would have to continue. We would have to go through no, I have started, the way I've started with this is just seems wrong, and I've worked my way into some rabbit hole here. Right. Can I link this problem to any established pattern? I don't want to continue going down this path, although I think I should. Let me just go down this path and then come back. The idea here is starting with a single digit, we are going to increment every index. Starting with a single digit, no. Let me not call it a single digit. Starting with an array containing a single digit, we're going to generate further digits from that. That's what we're doing here. For everybody for let I less value I less than ordering that length. What do we need the length? Equals the push ordering. Now we could, what are we looking for? We're looking for the one with the max value after multiplication. Okay, fine. Now we could attempt to store every value in the, okay, so this is like we don't want to store every value in the area of orderings to evaluate. We can just evaluate them on the fly. I think that's what we should do. So that reduces, but just assume we have the memory to store everything. Even if we did have the memory, I think we should just limit it to evaluating things we have not seen before. So in other words, using a hash set. I think I'm optimizing without even getting to a final conclusion. Let's see, about 30 minutes on this so far. Let's just assume equals of for each, cool. Is that it? Something seems missing. Is this really what I had in mind? Okay, well, I was just looking at if there was anything I could close, but my fan is on it again. Gosh, right. It's amazing how the Mac. Anyway, I think it's amazing just how doing the most little effort thing on your Mac, like recording, always leads to the fan going off. But yeah, back to points. Up until we achieved K cycles, we are going to go through every digit in the array of orderings of digits to evaluate. And then for every single one of those digits, we are going to increment a single index in the digits between I plus equals to 1. Unfortunately, if I print this out, I don't even know the length of the length to expect. That's bad. So we'll think about that. Return nonce. I believe return nonce. Let's run the code. Why is that pen? 4.8. If we have a nonce of a particular length, first of all, that's going to give us norms of length n will give us, in the first cycle, it will give us what? It will give us n new digits. The second cycle will give us n times n. So at 0 we have 1, at 1 we have n, at 2 we have n times n, at cycle 3 we have n cubed, at cycle 4 we have n to the power 4, 5, so at cycle k we have n to the power of k, we will have n to the power of k, what do you call it, digits in total. So this is a k is equal to 2. Okay, cool. So just have that's okay. Plus equal. All right. So it's something we should be able to evaluate. Wait, why can't I? Okay. Plus. Oh, all right. That's so weird. Can't I evaluate this before pushing it? Can't we do that? Oh, I see. What means I plus first of all, and then allows the push order. Yeah. First of all, remove that. I don't know what type it's inferring there. Second of all, type number is not assignable type. I don't. Okay, so this is from line 31. Oh my gosh, number. Okay, let's return 0. And then what? Okay. Not return anything because we didn't initialize this with norms. Shouldn't put it. Just put it like that. That was what I was saying. 150. And the way it's returning this is actually wrong. It's just doing the same thing over and over again. What did we expect? We expected an array of length, much more than this. This is really terrible code. Well, we expected in total n square options for 2. Let's fix this. First of all, let's optimize a bit. Let's separate things out. Second of all, so hard to express this. for C, C++, no. Okay. Let's start with 1. No, let's start with 0. And yes, let's start with the first row. And then for every ordering in the first row, let's go through every single digit in that ordering increment. That's bad. We don't want to just end up with a fully incremented. I want to increment 1 digit and forget about. Okay. We don't want to do that. We want to we could just do something like that'll be a pointer. Okay, we'll just clean up I++. Yeah. What else? Does this leave us? So in the first iteration of this, 0 is nums. We load in the nums array, and then I go through the nums array, increment the first one, push to the that ordering decrement. This is a pointer, we can't do that. We want to push a copy. Let's see. I don't want to do this. Yeah, copy begin. Let's see. What's the easiest way to copy an array? I guess that works. Just use your array from. Okay. Let's do this. That's a lot of return exactly what is there. Okay. I don't know if that's correct. Let's see what we have. Expected a comma. Okay, cool. That was 924, right? Yes. What do we have now? Length does not exist on type number. 41 does not. 22. That's not a number. Nums is meant to be an array. Nums is an array. It's not a number, so I'm doing something wrong. C0K C++ equals C equals 0 dot for each. I see. Equals C. This for each, is this redundant? Nope. It's not. We want an array within arrays. We want arrays within arrays. Oh gosh. Damn it. This is the worst. L0 dot for each must be like a closing thing. For each ordering. Let's see how far I got. Okay, 0, 4. Why am I starting with 0, 4? All this while I've been, I want to use the smaller k factor. That would make it. Enter k is 2. Let's use this one. Okay, cool. There's a runtime error happening. Maybe an index. What happens here? What happens here? Process. And also, what happens after I push to the evals? I want to see. Okay. So 3 to we start increment, I think, yeah, 7, 3, 3, 2. C plus 1 does not exist. Okay. C plus 1 does not exist. It's most likely the issue. If we're confident in how long our array should be, in terms of n to the power of k, then let's do constant equals classify the new array of the length, nums of length, not the power, nums of length to k. Is that correct? Not the power. And is the order correct? 7 to 3, 4 to 3, yes, I think that's correct. In which case, evals 0 that's the number of items we're going to hold, not necessarily the length that we're going to have. At the end of the day, we're only going to have the length of k, actually. I don't need all this. Each of those are going to be really long. And each of those will... Yeah, I think that's enough. Since we're pushing, no, that's not enough. We need to initialize this structure. Okay. And the way I want to do that is to do that, and for each of those I want to do, make this work, will this work? Sorry, let's assume this. Okay, that seems to be fine. We're still getting a runtime error. We're still getting a runtime error. What values are we actually? Okay, cool. I don't want to put. I want to see the final. Don't really care about all this noise. Let's remove this noise. Let's run that. Okay. Okay. What's going on? Oh, okay, chill. Control minus, plus plus. Remove the wrong statements. It's still a flat array. That's interesting. Runtime error. I think this is okay. And those statements equivalent. Don't need the semicolon. Okay, cool. That's a relief. What is going on there? It must be something to do with my for loop and clause. Something. We only go through. I don't even find our 6433. I expected this to, yeah, this is incomplete. It stops at the second level because I told it to stop at the second level. Or wow, this is a really bad experience. I'm doing very badly here. But let's see. I kind of know I guess trying to work out this brute force first was a bad idea because but then why not? I mean, let's assume we have infinite memory. Let's see what's going on here. It's stopping at the second level, which is this. We want it to continue. We want it to go through every single one of these. Kind of like looking back at the previous level, While we haven't seen something we've done before, that's been better end case, but K is definitely not the end case we're going for. Even still, why do we have a runtime error? Why do we have a runtime error? Okay, let's see. On the second, when K is 1, starting with 0, we do equal 0 for each ordering, and then we do this. push to what you want. Then when it's one, go through all those. Okay. There we go. And when we remove this, what's the final equal? 6433. Why did I? There's something still fishy about this end statement, but it looks okay. So we go through all the cycles, and at each cycle we look back at the previous cycle, at the previous level. That took an ungodly amount of time, but yeah, that was the idea. Gosh, wow. We're here now. Let's, oh, also, ew. Ew. Let's remove that. Space that out. So this is assuming we have infinite memory. Our answer will be in here somewhere, and then the next step will just be to reduce this to find we're not even returning the sequence, we're just going through all of this and returning the maximum number, which makes it easier to reduce. So let's do that. How much time? I guess it seems like I'm only going to be able to spend to solve one problem, which is this one. Let's do the reduction. What's the reduction like? We're going through every single cell in this matrix, and we are looking for the smallest number, no, largest number. So evals.reduce, evals.reduce. What does reduce take actually? God, wow. Array.reduce, reduce. There we go. It takes the previous value and it goes through every. Okay, we can do it row by row then. Kind of like if it's, let's see where this is going. Let's just do it. Yeah. Let's just do it. Previous.reduce. I don't like the way this is structured. I'm just going to do this imperatively. So one thing I'm learning about myself is I definitely prefer imperative programming, which I don't know. It's always just more verbose than functional, and I do want to up my functional proficiency because it would save me a lot more keystrokes. So evals.for each array or row, let's just call it row. What we're going to do is reduce that row. Constant rest, constant results. row dot reduce. We will take the previous value, the current value, and what we're going to do, no values arrays. We're reducing that row. I keep forgetting the syntax. Reduce takes, okay, it takes a function. And go. For Christ's sakes. Okay. And let's see. First of all, we reduce the row. Return. Let's just return the mean. Let's just say mean gets mean. And let's just say mean gets the value mean comma the reduction, and then let's do the reduction. Let's do the reduction. These are arrays. I actually want us to get to the point where am I doing this wrong? Where let's just go through row dots for each. Let's just get a single level reduction. Row cell. I guess this is a cell. And then let's do this inside that cell. Okay, so now we have not array, not, what do we have? We have single arrays, not arrays of arrays. Mine, not the mean row, cell, reduce previous current, return, pre, Oh, but doing the reduction, right? Starting with, what's the initial value? 1. Where does this videos end? The initial value, let's give it an initial value of 1. Return prove times current. I think that's what I want to do. I think so. Return mean. Let's just run it. It'll tell us our errors. Answer is 0. Great. Is it because of how nested it is? Even though you should be able to get scope from there. At the mean, comma, oh. Not the max. Is that how you do it? I think so. What's max integer? Max integer. Max binary. Number. Yes, yeah, math is for the operations and number is for the number that max value. Okay. Apparently we got a smaller number. Not the max, not me. Wait, what am I doing? I want to return the maximum value between this will always return this should be 0. And then the issue was I was returning me not max, I think. So let's try that again. Okay, cool. So, I mean, for the second problem, we seem to have got an answer. This is really bad, though. Like, the amount of space we would need. Like this is just k is equal to 2. And k can be 10 to the power of 5. Yeah, no, this is bad. K can be 5, but would that be a max out of memory issue or a runtime issue? Let's look at the runtime of this. A eval C. Okay. I mean, that looks like an optimal runtime to me. We are only ever looking back. I don't know whether it's possible that we'll be looking at duplicates. We can eliminate duplicates in all one time just by using a hash set. If that's an issue, I don't know that that's an issue. Let's look at in this sample case so that we actually saw issues. Duplicate. In this sample, yeah, whether we actually saw duplicates values, and then we can eliminate operations on those. Also, I'm just not going to focus on optimizing memory. I'm going to focus on optimizing runtime. It seems to me that they should all. Let me just submit this and see what we get first of all. Bad alloc. I have never seen this before. What does that mean? Let's see. Oh my god, K58, yeah. How much space do you need? That's a lot. But I want to confirm that, I'm just going to copy everything. I want to confirm that bad alloc means I'm trying to allocate out of bound. Like, I'm trying to allocate in memory that doesn't exist. Oh god. Yes, we're using too much memory. Okay, cool. So I think the difficulty in this all along was going to be a memory optimization problem. Let's not store these. Let's evaluate the marks as we go along, right? So we want to, since we're here, yeah, I'm going to push this up here, and then we're going to run this, rather than evals or push, while we're pushing an array, right? And effectively we're pushing a cell in the array at each point. So we're just going to cut this out. I think that's where that ends. Let's see, where is that first? Yeah. So I'm going to cut out this operation we're doing. We can comment this all out. We're going to put this here. And then what else are we going to do? Let's indent. Yeah, kind of. This breaks apart immediately because we are trying to. It just breaks apart straight away without access to like some previous. Well, what do we need? We need the last level. We can delete stuff as we go. And that's one way to do it. We always need to have at least one level of digits, of arrays of digits, of ordinals, to generate the next level. When we generate the next level, we can delete the last level. We never need to maintain all the levels in memory. That's just pointless. Okay, so I think we're still good with copying this in, but when we're done, we're preparing for the next evaluation, right? Okay. Let's see. What I'm thinking of is this cell, by the way, needs to be changed. Okay, let's do that, and let's just put that as cell. Cool. Okay. So what am I thinking? Let's not think. Let's just read. At this point, we have a cell. Cool. And then we're going to push that cell into the next level, but we're going to evaluate the cell now. So my brain is tired. We do not want to evaluate the cell twice. What do we want to do? We want to evaluate. So let's say we're evaluating the cell at the point of creation. Let's just make that more obvious by pushing that up there. The only thing we need that cell for now is to create. So we're never going back to the previous. I think this is fine. Yeah, I think this is fine. The only thing that's left now is deleting the previous level eval c dot for each for let's see let's how do you delete from an array? On shift delete. It's just something off. Starting with the first level. Oh, do you know what? I don't think we ever evaluated eval c. Oh, okay. The first thing we should do is yeah, why not? We should get the reduction of we should get this reduction. That's the first thing we should do. Yep, and then just the exact same thing. Cool. So that solves that issue. Next things, from that first ordering, we are going to generate. No, let's just do the generation first. Why is this so hard to visualize? We have the cell, and then we generate the next level. When we're done generating the next level, I want to delete the previous level. I don't need it anymore. Okay, let me just note that by deleting the previous level. But before moving on to implementing that, I want to note what exactly is going on. My brain keeps coming back to this point, like I'm doing repetitive work. In the next level, I'll be reducing cells in the level c plus 1 plus 1. So no, I'm not doing repetitive work here. Okay. Now the question is, c dot for each. This is not where we're done. This is where we are done. Okay, so just before I even implement this, what does that give us? It means hmm, that's a lot. That's a huge number. It's better than a summation. At the last level, I wrote down that we would need n to the power of k iterations, right? And the limits we have here are that k can be 10 to the power of 5 and nums can be 10 to the power of 6. So the question I'm going to ask myself is, can I store 10 to the power of 6 to the power of 10 to the power of 5 in memory? I don't know. That's 10 to the power of 6 is, given this array is more than, let's just assume 10 to the power of 6 is 1 MB. 1 to the power of 1 within 1, that's just not good. Oh, that's 10 to the power of 6 times 5. Okay, that doesn't mean 10 to the power of 30. Oh, I actually don't have benchmarks to, I don't have benchmarks to size this again, so I'm just going to try it out and see. But 10 to the power of 30 doesn't seem impossible in terms of numbers I've seen being stored. So the question now is, how do I delete a row? Equals dot I actually have no clue. Like, yes, I know about those, but how do you actually delete? Okay, let's just look at the documentation itself. You could create a new array? I don't know. Of the remaining that you can. Let's look. Concats, entries, find, flats, flatman. Shifts. Shift. Let's see. Okay, now. How about pop? Code. This is what we want. But not pop. We want the opposite of pop. Isn't it on shifts? No, it's not on shift. There must be something that's like removes just the first. Push, reduce, right, reverse, shift. Let's look at shifts. This method changes. Okay, cool. First. Okay, I think this is it. Yeah, I think this is it. So we just want to shift. I don't care about that. Let's first of all check. Oh no, so many issues. First of all, line 37. Wait, what? Did this thing actually run? Okay, it did. Line 19 says that's interesting. Argument of type unknown is not assignable to parameter of type number. That's very, very weird. This is a number, and obviously this should be able to infer a number return type. Except maybe it doesn't know that cell is going to be a number. How? This TypeScript and sometimes let's just tell it, look, this is a number array. Okay, so that's our issue. Okay, seems to. And then how about 15? Type unknown is not assigned to type number. Okay, so I guess can I do an assertion like that? TypeScript, come on, seriously, you can't refer this. What am I doing wrong? I can't refer. I have no clue. Okay, cool. Answer is wrong. I'm meant to get 216, but we get 162. Let's remove this and focus. I mean, maybe it's useful to reference that actually. Oof. Why did we get 162? 162, 162, 162. We're probably not seeing the cell that we want to see, or it has something to do with the way I'm initializing mean. And initializing mean. What's the initial value of mean? And does that value actually get updated? Okay, it does. Maybe we're just not. I can't remember now. I can't remember the level at which our final answer was. I think it was at the last level. So I think it's likely we're not evaluating. Yeah, we're forgetting to evaluate the last level. At this point, we should have an array that is one length long, basically. Let's confirm that, and then let's just make sure that we evaluate. Yeah, that we evaluate. It's taking so long. That we evaluate that level. It's empty. It's empty. We need to do it before. It's empty. I expected to have the level before and the n-1th level, generating the nth level. I expected to come out of this and delete the n-1th level and still have the nth level to come out of this. But apparently it's empty. In which case, I want to see what's happening as we go. I made a huge mistake that I just can't. It's not popping into my mind. I can't see. So it's empty. Not only that, you don't actually generate the winning level. We're starting with 0, 0. Let's see from the beginning. going on 2 hours. I thought I'd spend an hour, but I mean, I just want to solve this. Okay, we start with 0, then we generate. I mean, we're deleting as we go, right? So it's gonna be hard to make out, but let's keep that back. Okay, yes, and then we end up with that, and then we start with that, but we don't generate the next one. Oh my gosh, it's the indexing. Ugh, the same issue as the last problem. As we delete the index changes. We get index, we get eval 0, and then from eval 0 we're able to can I just do this without indexing? But if I simply we can hard code that index 1 we can hard code that to eval to 0. Yeah, that looks fine to me. Let's do a console.log there. Remove that, and run. Still wrong, and then a runtime error. Okay, so that was, should have thought through that. This means we only ever need an array of length 2. And what else? Yeah, this is what it means. And we start with pushing nodes into 0. We have a minimum value. We don't need this verification anymore. And what else do we want to do? We then cycle through. Yes, and we always start with 0, and for each ordering, yes, 0, ordering, yes, and then we always push to eval 1, push cell, and then reduce, we correct, and then we unshift. This shift, we could just do rather than a shift. Just do a pointer, an update of pointers, and then yeah, new array should be fine. And we can trust JavaScript to do the remainder of the garbage collection, but that should hopefully take us back to the problem of not evaluating the last this is surprising. It does evaluate it because we are evaluating level as we go, which is what we concluded on before, right? It evaluates the next level in the current loop. Everything that has been generated for the next level has been evaluated. Okay, let's see what this gives us. Oh no, wrong, submit. I have low hopes because it seems like just such a hard to get that solution. Cool. Again, K58 is giving us an issue. It says let's get hit out of memory. Okay. eval 0, eval 1. I'm not deleting it though. I don't think that's an issue. Okay, okay. That just looks fine. In terms of the optimization I was going for, that looks fine. I don't think JavaScript keeps arrays that we're not pointing to around. I think it deallocates them in memory. I mean, I can confirm that, but I'm pretty sure. So, so maybe it's time to think about what memory requirements this actually needs. I already concluded that it needs n to the power of k. That's such huge memory. That's huge. N to the power of 15. Even though what we have here is 2 to the power of 58 is crazily huge. And it doesn't need just to the power of 58. It needs to the power of 58 plus to the power of 57, which is shy of, yeah, that's a lot, which is just shy of, I think it's about 59, I think, yeah, 2 times, yeah. So what do? I need to come up with something that requires way less memory and just does it cell by cell, not row by row, right? Cell by cell. But I'm not going to do that today. I am going to continue this next week. In terms of the kind of problem this is, I think in terms of, I think it's good to try to categorize this into a particular type of problem so I can read up on it. So, off the top of my head, this is either a linear programming or a dynamic programming problem. With linear programming problems, kind of like you have an oil field, you want to determine where to place oil rigs to optimize oil outputs. That will be something I think that will fall under the category of a linear programming problem. You're optimizing placement, or you're optimizing, what do you call it? You're optimizing variables. What I'm looking for is the name of that thing in like equations where you're optimizing the different factors. But yeah, I think that would be a linear programming problem. So this looks more like a dynamic programming problem where, what is the example I use for a dynamic programming problem? You have sets, huge sets, and you're trying to find, basically it's a program that's generating huge sets of values, and you want to optimize for, you want to reduce that in some way. So there will be techniques I'm sure I'll learn in terms of dynamic programming techniques that would make this problem, that would solve this problem much more efficiently. And off the top of my head, it will probably just reduce to something like, rather than storing cells, let's get to the point where we're generating, so evals or push cell. Why am I pushing? I'm pushing so that I can generate the next level, right? But can I just do that on the fly without stopping to store it in memory? Is what I'm going to probe here. Maybe I'll just look at the solutions, but yeah, this was fun, even though it was so long. I really enjoyed this. I'm looking forward to continuing this problem next week, next weekend. Thanks. Yeah, thanks for if you watched this and oh my god, thanks. It's amazing to know that people are interested in seeing this sort of content or seeing someone walk through problems like this. But yeah, see you guys next weekend.